G'day ladies and gents, Cubic Meter here with some profound tech using movable talencies in Java Edition. Of course, this is not yet possible in vanilla, which is why we're using 2No2Name's implementation of movable talencies through Carpet mod in order to experiment with the feature in Java Edition. This here is an instant item sorter. It is capable of transporting an item via hopper line instantaneously over infinite distance in such a way that an item filter can actually collect the item. I'll just demonstrate by throwing an item into the input. That item, the instant that it entered the hopper line, made its way into the item filter in a single game tick. Your first thoughts might be, cool, I can now instantly sort items in my storage system. Well, not really. Only a single item can be sorted at a time at 1/3 hopper speed. The speed limitation will become clear when we look into the hopper mechanics. So if not for sorting items, what is instant item sorting even good for? Well, it enables constant time decoding. To understand why this is significant, we should ask an age-old question. I have a storage system containing every stackable item in the game. Can I build a redstone contraption which delivers the item I want from the storage? Ultimate Redstone had a crack at this one all the way back in 1.8 with his magical storage system. Granted, this was before the time of shulker boxes, but his method of using books to encode the desired item was pretty advanced. These days, however, it's much simpler to use the item itself to encode the information, such as with the famous example of Iscal's core-based system for the Sahara Superstore on the Hermitcraft server. But all these concepts have a critical flaw. Storage cells closer to the input receive the items faster, and therefore have a better response time than storage cells further down the line. This issue can be illustrated in one of my own designs for a core-based storage system. With this design, I was shooting for the fastest delivery of items possible. The delivery is made using an instant dropper line. This means that no matter how long the storage system is, at least the output is constant time. However, the bottleneck is still at the decoding stage, denoted in blue. An instant dropper line doesn't work here, because from the perspective of hoppers, the item is effectively teleported through. The system I'm using here is a sort of dropper bolt, which transports the item at 20 blocks per second. Just for reference, 20 blocks per second means that the item spends a single game tick in each dropper, meaning that is the absolute fastest you can transport an item through a dropper line and have it collected by an item filter. This particular storage system stores every single item in the game. There are 736 stackable, survival obtainable items as of 1.16. So if I were to stack all the storage cells in a straight line, it could take up to 36.8 seconds to deliver an item. That is why, to mitigate this issue, I separated the storage into 4 quadrants, each 184 blocks in length. But even with this tactic, it can still take up to 15 seconds to deliver an item. If I select an item close to the start, it ends up being delivered pretty quickly. If I select an item around the end, it will take much longer to deliver. And this is simply not acceptable. As you can tell, it's long enough to start feeling awkward. The dream of constant time item sorting laid in the wake of research done by technical players around the world. One such player, Senshi Roll, who I like to call the goddess of dangerously overthinking things, spent months researching the ways in which hoppers are loaded for tick priority. The thing is, instant hopper lines were real, however they were very unstable, and had previously only been observed in situations where the game would just randomly load hoppers in the correct order. A breakthrough was the discovery that you can just manually place the hoppers in the correct order to make a working instant hopper line. fact, I can do it for you right now. Just place down the hoppers in the following order. Make sure they're locked somehow. And add a system that allows you to unlock them for a very brief period of time. Now you'll need to put a dummy item in the second slot of every hopper. The reason you need this dummy item will be explained later on when we look into detail to how the hoppers work. I'll also add a detection system at the end so we know when our item has arrived. And now all you need to do is place whatever item you want to send through the hopper line in the first slot of the hopper at the very start. Trigger the system. As you can see, the item has arrived instantly. Now I will show you what happens if you unload and reload the chunks that the hoppers are in. This can be done by simply closing the world and then reopening it. The item is still in the first slot. If we activate the hopper line now, we look into the chest, and one of our dummy items has made it here instead. And we should find that our item has gotten stuck somewhere in the hopper line. Here it is. So this configuration is very unstable, and in fact, every single time you reload the chunks, you need to manually replace every single hopper. So just to verify this, I break all of the hoppers and place them back down again in the correct order. Refill the dummy items. Now verify that it works once again. So while instant hopper lines are real, they're pretty useless if you have to replace every single hopper every time you reload the chunks. But this is where we can use a bit of MTE magic to fix things. Using quasi-connectivity, you can chain block updates such that they can automatically replace the hopper line for you. And now we can observe that it works perfectly. This is because when a piston moves a block, it basically removes the block, saves it to the data of the moving piston, and then replaces the block at the new location. Which means if you move a hopper, you remove the hopper from the world, convert it into the tile entity of the moving piston, then convert it back into a hopper in the world. This effectively resets the tick priority of the hoppers, which is important for the instant hopper line to function. So now we can automate the resetting of the hoppers. How about the instant smart storage? Here we have it. A 500 block long smart storage system capable of sending items to the player on demand. Every time you reload the system, you need to activate this instant wire, which resets all of the hoppers. Now the system is primed and ready to deliver your items. Now I can grab some items. And either request them one at a time, or I can even request multiple items at the same time. And with constant time, There is always going to be a 1.2 second delay between me requesting an item and receiving it in this shulker display. I've even connected the shulker box display directly to the instant dropper line to ensure that there are no delays whatsoever. In order to achieve this, our shulker box displays use a little bit more movable block entity magic. As you can see, the display is directly connected to the instant dropper line. So if you send a box through, the instant the slice receives a box, it will replace the upwards facing dropper for a sideways facing one, and now it will send the box to the next slice. The result is that we get a consistent amount of time between each box being placed down in our shulker box displays. In case you haven't realized, this is huge. Not only can this be used for the ultimate smart storage, but has many other applications in binary redstone, as you can send extremely complex messages over infinite distance in quick succession. To understand the possibilities, you must consider that even though there are 736 stackable items in the game, you can rename them using an anvil. This gives you the option of anywhere from 1 to 34 fields in total, in which you can place a character. In each field, you have an option to either place a character or not place a character, meaning using binary alone, you obtain 2 to the power of 34 combinations in total, which is about 17 billion. Then consider that you can not only type out the values 1 and 0, you can also type out every other character available to you on the keyboard. This brings the number up to 95 to the power of 34 combinations, or 17 uvigintillion. This, by the way, is the exact amount of seconds it takes to break bedrock with a netherite pick. And if you thought things weren't already insane enough as they are, there are 1,114,112 characters in total in Unicode as of the latest version, giving us that number to the power of 34 combinations in total, which is a number 206 decimal points in length. Alright, that's enough mind bending for today. Let's figure out how instant item sorting works. You start with these one wide tileable segments featuring a basic item filter below your instant hopper line. This filter has been extended to allow for the addition of other components whose purpose will be explained later on. On the opposite side to the item filters, we have the tick priority reset system. Here we have the sequence in which the hoppers are placed. For each segment, we must ensure that the item filter is placed before the transmission hopper. In order to achieve this, we use the movement priority for slime and honey block structures. When retracting, blocks closest to the piston head will move first. However, when extending, blocks furthest from the piston head will extend first. Therefore, the filter hopper down below arrives first. Then, our transmission hopper is placed. This ensures that these two hoppers are in the correct tick priority. So now we have the hoppers in the correct order. How do we get them to push an item in a single game tick? Whenever you want events to occur in a single game tick, you must look at the way the game schedules events. With the tick priority set, the hoppers will be processed every game tick in the order we defined. Each hopper in the chain will then execute a set of tasks. To start with, the hopper will reduce its cooldown by 1 if non-zero. This is to do with the fact that each time a hopper pulls or pushes an item, it has an 8 game tick cooldown before it can do so again. This limits the speed at which hoppers can transfer items. The hopper will then check whether it's being locked by a redstone signal or whether it's still in cooldown. If it's in cooldown or it's being locked by a redstone signal, the game will then proceed to process the next hopper in the chain. If, however, the hopper is unlocked and is not in cooldown, the game will check, is the hopper empty? If the hopper is not empty, it will locate the first slot which has items. It will then locate the first empty slot in the destination where the hopper is pointing into. If it succeeds in finding a slot to put the item into, it will check whether the destination is an empty hopper. If the destination is not an empty hopper, like say it is a chest, it will transfer the item and set its own cooldown to 8 game ticks. However, if the destination is a hopper that is empty, it will also set the cooldown of the destination hopper to 8 game ticks. The reason a hopper does this is to ensure that if you have an empty line of hoppers, the items will flow in a predictable and consistent way. In fact, if consecutive hoppers weren't locked when initially receiving items, whenever you first throw an item into a long hopper line that's empty, there's a chance that some of the hoppers may have been loaded in the correct tick priority, and therefore the item will be instantly transported through them. And due to the unstable nature of instant hopper lines, this would make hoppers very unpredictable and unreliable. Therefore, this is a very critical step of our hopper's execution. So now, what happens once the hopper transfers the item? It will now check, is our hopper that was initially ticked full? If it is full, then it will simply proceed to processing the next hopper in the chain. If our hopper is not full, it will check whether it has an inventory above it. If it does not have an inventory above it, it will attempt to suck in a single item entity from the world. If that fails, it will proceed to the next hopper. However, if it succeeds in sucking in a single item entity, it will set its own cooldown to 8 game ticks. If it does have an inventory above, however, it will attempt to pull an item from that inventory, and then proceed to set its own cooldown. If that fails, it will proceed to the next hopper. Let's keep in mind that the odd numbers represent all of our filter hoppers, while the even numbers represents all of our transmission hoppers. In every single game tick, our hoppers will be executed in the following order. So we start with our filter hopper. It's always enabled and it shouldn't be in cooldown. A hopper has items in it, which is our dummy items and filter items. However, we have pointed this hopper away from any inventories, because we don't want it pushing items anywhere. A hopper isn't full, it's always below the threshold defined for our item filter. We'll then check if there's an inventory above, which will be our transmission line. They'll attempt to pull an item from the transmission line, and then eventually proceed to the next hopper. Once the item filter has been given the opportunity to pull an item from the transmission line, it will then proceed to process the hopper in the transmission line. Most of the time, our transmission line is actually disabled, but in the case that there is an item to transfer, we will briefly unlock the system, and the game will check whether it's empty, which it isn't because there is an item there to transfer. It will now look for an inventory to push the item into. Now, if our destination hopper in the transmission line doesn't have any items in it, it will then lock the hopper in front with an 8 game tick cooldown, which means our instant hopper line wouldn't work, because every time the hoppers transfer an item, it will lock the hopper that's next in the line, and it will simply function as a normal hopper line. So we want to avoid doing this. What's the alternative? Well, we have to make sure that the destination in the transmission line is not an empty hopper. And the only way to do this is to ensure that the hoppers in the transmission line always have items within them. This is in fact why we're required to have a dummy item in the second slot of every hopper of our transmission line. Now we have successfully transferred the item into the next segment of the transmission line, we can proceed to process the next item filter. It will check whether the item is compatible, and if not, it will simply proceed to the transmission line hopper above that item filter, and the process is repeated. We'll then move the hopper into the next segment of the transmission line, and this will all occur within a single game tick. But then you run into another problem, which I will now illustrate. The issue is that we lose a dummy item every time an item is sorted. When the item gets sucked out of the transmission hopper, the corresponding segment will instead push its dummy item out, leaving a hole. The next item you send will get trapped in this hole, then the next segment will lose its dummy item. So before you can send the next item, you must replenish the dummy item somehow. In order to do this, we have this additional system in each segment, which is able to detect if the segment has lost its dummy item. Detecting when a segment loses its dummy item is important. So if I send an item through, here I've just disconnected the system which does it automatically, so we can go through it step by step. So now we've sent the item through, it's been pulled out of the transmission line and left this hopper without its dummy item. And this comparator has detected that and forced this sticky piston to extend. While this is extended, it blocks this sticky piston from pushing the redstone block out. It also prevents this hopper from unlocking. In fact, because this entire bank of sticky pistons is powered using quasi-connectivity, if this piston is unable to extend, it will not send an update to its neighbor to extend, and so on. So in fact, none of the hoppers beyond the one which has lost its dummy item will be unlocked the next time you activate the sequence. And this is important, because this means that this empty space won't propagate down the line each time you activate it. If you had to wait for the hole to be cleared throughout the entire line, then that would make this whole process prohibitive. So let's now replenish the dummy item. Here we activate the second part of the sequence. As you can see, all the pistons up until the point where the dummy item was missing extended. And now we've dropped the dummy item into the first slot. In order to move this to the second slot, we'll need to activate the system one more time. And now, you can observe it has moved to the second slot, and the whole system is ready to be used again. Replenishing the dummy items is in fact where the 1.2 second response time comes from. This is because we need to wait for the system to be activated 3 times before we can send another item to be sorted. This is due to the hoppers being put into cooldown each time you activate the system. So you need to activate it 3 times, and the hoppers have an 8 game tick cooldown. That makes for 24 game ticks in total, which is 1.2 seconds. But the major advantage of this system is that it has constant time. And you can observe this if I put this shulker box full of various walls to the input. Pretty satisfying to watch, isn't it? So what you just witnessed was the control system at the very beginning, going through the entire sequence of sorting the item to replenishing the dummy item in 24 game ticks. All we do is detect when there's an item to sort and activate a 24 game tick fader clock. This will activate the sequence to sort the item, then replenish the dummy items, and also dispense new dummy items into the beginning. In order to resupply the system with dummy items, you can just have a buffer here. Then at the very end of the hopper line, you just have a collection system which loops back around and recycles the dummy items. This way, you don't ever lose any items. There we have it. In case you wanted to play with the concept yourself, I'll be leaving a world download in the description. But a few things to note. Always remember to reset the hoppers before using the system. Make sure you have movable block entities enabled. And be aware that this storage system is over 500 blocks long. So if you want to try out the storage system, you need to make sure that you have your render distance on maximum. Well, that was one heck of a long video about a hopper line, but I felt I could spare no detail for something with such huge potential, and I would love to see what contraption people in the technical community can come up with using this. I for one am excited for an upcoming project involving the Universal Autocrafter, using instant item sorting to select recipes. That's gonna have to wait for another video, so I'll see you next time.